If you pick up a prescription at the pharmacy, you might find a bright yellow sticker slapped onto the side of the bottle with a very specific command: do not consume grapefruit or grapefruit juice. We expect to see warnings about mixing medications with heavy machinery or alcohol, but pharmacies treat a standard vitamin-rich citrus fruit, something normally marketed as part of a healthy breakfast, as a biological hazard. The warning stems from one of the most potent food-drug interactions ever recorded, a discovery made entirely by accident. This image from 1989 shows the clinical environment where clinical pharmacologist David Bailey first encountered the mystery. He was running a trial to test how alcohol interacted with a drug called felodipine. Felodipine is a calcium channel blocker routinely prescribed to lower high blood pressure. To run a valid double-blind trial, Bailey needed to ensure his test subjects couldn't tell whether they were drinking alcohol or a placebo. He needed a liquid capable of hiding the sharp, unmistakable taste of ethanol. His specific solution was highly concentrated grapefruit juice. The tart, bitter profile of the citrus served as the masking agent, hiding the alcohol perfectly. When the researchers analyzed this data on their monitors, the results were alarming. Patients' blood levels of felodipine had spiked far beyond safe limits, reaching concentrations several times higher than anticipated. The researchers looked at the placebo group and realized those patients also experienced the surge. The alcohol wasn't causing the drug levels to rise. The grapefruit juice was. A simple trick to hide the taste of alcohol had exposed a hidden biological mechanism that dictates how oral drugs are absorbed into the body. To understand what the grapefruit did, we have to map the normal journey of an oral pill. After you swallow a medication, it travels through your digestive tract to the walls of the small intestine. The gut wall is lined with CYP3A4. CYP3A4 is a specialized enzyme that acts as a biological gatekeeper, designed to break down foreign molecules before they can enter the body. These enzyme bouncers destroy a massive percentage of the medication right there in the gut. This filtering process is known as first-pass metabolism, and it prevents most of the chemical from ever reaching your bloodstream. Pharmaceutical companies formulate standard oral dosages high enough to survive this encounter. They know the drug must survive the intestinal enzymes to be effective. Because of our natural intestinal defenses, a medication must be heavily dosed at the point of ingestion just to get a functional therapeutic amount into our blood. These crates of Seville oranges contain unique organic chemical compounds called furanocoumarins, which are also found in grapefruit and tangelos. Furanocoumarins are natural plant defense chemicals produced to ward off insects and fungi. When consumed by a human, these compounds act as suicide inhibitors against the gut's defenses. A suicide inhibitor is a molecule that permanently binds to an enzyme, completely disabling it until the cell dies. The grapefruit compounds lock on to the CYP3A4 enzymes and destroy them. The reaction is irreversible. A single glass of grapefruit juice contains enough of these compounds to wipe out nearly half of the CYP3A4 enzymes in your intestines in just 4 hours. With the enzyme bouncers dead, the heavily concentrated, unmetabolized dose of the drug faces no resistance. It floods across the intestinal wall and straight into the bloodstream. The juice doesn't poison the drug. By disarming the body's primary defense mechanism, the fruit turns a strictly calculated normal dose into a massive, uncontrolled overdose. Since Bailey's initial trial, the scope of this interaction has expanded. We now know this specific enzyme destruction affects over 85 different common medications. You cannot bypass the problem by taking your pill a few hours later. Because the destruction is permanent, it takes the body 1 to 3 days to manufacture a fresh batch of CYP3A4 enzymes. For decades, this mechanism generated intense medical warnings regarding severe liver damage and rhabdomyolysis. Rhabdomyolysis is a life-threatening condition where decaying muscle tissue floods the kidneys. This statin medication box represents the focus of recent clinical audits. Researchers have begun auditing hospital data to see exactly how many patients are showing up with these severe side effects. Comparing the biochemical destruction in the gut with actual hospital records allows us to see the true threat level to everyday patients. Recent medical meta-analyses have looked closely at patients taking statins, the medications used to manage high cholesterol. The statistical risk of severe toxicity or muscle breakdown is low, hovering around 1 or 2 incidents per 100,000 patients. Some researchers now reframe grapefruit juice as an effect enhancer for these specific cases. The juice delivers a higher effective dose of the statin, resulting in a more aggressive reduction in cholesterol and a lower risk of heart disease. Cautionary: there is a critical exception for drugs with a narrow therapeutic index, medications where the helpful dose is perilously close to the toxic dose. In these cases, the interaction remains a life-threatening danger. The bright yellow warning label demands strict respect and a consultation with your doctor. But for many standard prescriptions, the grapefruit interaction represents a fascinating quirk of human biology rather than a guaranteed catastrophe.